Good morning, dear friends. Let's solve summer 2024 IGCSE MCQ paper, physics. Yeah. In which row are the quantities correctly categorized into scalar quantities and vector quantities? Okay, mass and energy, yes, they are scalar, and weight and acceleration, they are lucky. First option. Gravitational field strength is vector, it's in scalar. Speed, momentum is vector, it's in scalar. Distance and energy, option D is scalar, but velocity and temperature is a scalar, that is in vector. So only option A. Which name is given to the quantity of matter in an object? Mass. Mass is a measure of quantity of matter. It's in the syllabus, yes. Okay. A body is moved from place X to place Y where the gravitational field strength is different. What happens to its mass and to its weights due to the move? Okay. So mass stays the same. Mass is not influenced by gravitational force or gravitational field, sorry. But gravitational force is result of gravitational field. So mass stays the same and the weight changes. So weight is gravitational force on an object that has mass. Yes. So option C. The mass of an object is 2.5 kg. The volume of the object is 480 centimeter cube. What is the density of the object? Okay, so this is very easy. Density is mass by volume, but what we have to be careful about though is mass is given in kilogram, but all the options are in gram per centimeter cube. So that we have to convert. So instead of mass, it's 2.5 into 10 power 3 gram divided by 480 centimeter cube. So if you do the math, it's 5.208 gram per centimeter cube. So we can round it off to 5.2. Option B, yes. Four objects each have two forces acting on them. Which object is in equilibrium? So we can obviously see that A is right answer, but we'll consider other also. So option D, both forces are acting from left. So the resultant force will be towards right. And option C, so one is in the center, other one is top. So the net resultant will be a torque. So it will rotate the body. It will go like this. Okay. Option B, it's complete torque. So one, they are equal and opposite. So the body will rotate like this. So option A, they are equal and opposite. So they will cancel out each other. So option A is the right answer. A ball of mass m falls vertically and hits a hard surface. Its speed on hitting the surface is v1. It rebounds vertically upwards with speed v2. What is the change in momentum of the ball? Okay, so first thing we have to understand that so initial velocity is v1, which is going down. Final velocity is v2, which is going up. So they are opposite in direction. So if one has positive sign, then the other should have negative sign. So we know that change in momentum is final momentum minus initial momentum. So initial momentum is mv1, final momentum is mv2. So difference in momentum is initial momentum minus final momentum. So mv2 minus of minus v1. So we can take either direction negative. Eventually we will get the same result. So it will give mv1 plus v2. So if we take v2 as minus, then we will have minus of mv1 plus v2. But still the same answer. So option C. A stone is dropped from a tall tower and falls a distance of 50 meters to the ground. The stone has mass of 3 kg. At which speed does the stone hit the ground? Okay, so we can, if you are dealing this question in AS or A level, then we can use equations of motion. Now we can just use the concept of energy. So stone is in this height, so this will have potential energy at this height. When it's dropped, the same amount of potential energy will be having as a kinetic energy. The stone will be having as a kinetic energy in this point to the ground. So we know that potential energy is mgh and kinetic energy is half mv square. They are equal. What's potential energy here? The same energy only it will have as kinetic energy here. Conservation of energy. So mgh is half mv square. We can cancel out mass. Gh is half v square. We want v. So if we We have to rewrite this equation for V square and then take the square root. V is square root of 2 GH. Rest is simple. G is 1.8 and H is 50. So 331.30 meter per second. Option B. A coal fire power station generates electricity. Coal is burned and the energy released is used to boil the water. The steam from the water makes the generator move and this produces electricity. Which row gives the name of the energy stored in the coal and the energy stored moving generator? Okay, so it's chemical energy stored in the coal, and remember that if the water is directly hitting the turbine and then it's hydroelectric energy, but the steam, which is fast moving water vapor, that has kinetic energy. That kinetic energy is used to rotate the turbine, so it's kinetic, chemical and kinetic. Option B. A man puts some ice into a glass of water on a warm day. After some time, he notices that the ice disappears and that water droplets appear on the outside of the glass. Which two changes of state are taking place? Ice is melting and water droplets are condensing. So it's condensation and melting. So option B. Gas of volume 200 centimeter cube is trapped inside a container by piston. The piston is pushed to the right and the volume of the gas decreases to 100 centimeter cube. The temperature of the gas remains constant. Which row states the effect that it has on the kinetic energy of the gas particles and the force per unit area exerted? Okay, so they are basically asking the kinetic energy and the pressure. Force by unit area is pressure. First, kinetic energy is property of temperature. If temperature increase, kinetic energy will increase. But here it's stated that the temperature in a constant temperature. So kinetic energy stays the same. How about pressure? Pressure is force by area. So if we decrease the volume of the cylinder, then the surface area inside is going to decrease. So force by area, this is inversely proportional to pressure. So force per unit area is going to increase by the amount they are decreasing. So they are decreasing by half, so it will increase by double. So less volume, less area. Less area means more force, double force. So option C. Which graph shows the relationship between the pressure and volume of a fixed mass of a gas at constant temperature? Okay, we know that PV is proportional to T, ideal gas law. If T is constant, then P is proportional to V, that goes side, it's 1 by V. Yes, I am sorry. Yeah, P is proportional to 1 by V. So the relationship between P and V is inverse. So it should look like this. So option D. During evaporation of a liquid, the most energetic particles escape. The temperature of the remaining liquid changes. Which row identifies where this particle escapes from and describes the temperature change? Okay, so the evaporation takes place only in the surface. Okay, boiling takes place in the entire liquid, but evaporation takes place only in the surface. So surface of the liquid, temperature of the remaining liquid will decrease because the most energetic particles will escape from the surface and they will carry energy with them. So the remaining temperature, liquid's temperature will decrease. So option C. Wet cloths are put out on a line to allow the water in the cloths to evaporate. Which type of weather would cause the water to evaporate more quickly? So it should be a hot day with wind. Why? The wind can carry more particles. So hot day with the wind. The common sense, yes. How lucky to have question 14 like this. Good. A solar water heater is designed to absorb energy from sunlight. Which surface structure and color would be the best for the solar water heater? So this is very easy to remember. Okay, we have two colors, black and white. Black is good absorber, also good emitter. White is good reflector. Okay, in this following we have two more category, shiny or dull. Shiny is good reflector, dull is good observer. Okay, that's all. So it should be dull black. because it has to absorb more and more possible energy. Black will absorb, in that dull will absorb more because shiny will reflect little bit. So a dull black. Which statement about wave is correct? This question has little uncertain attached to it. Wave transfer energy without transferring matter, but they should mention whether it's a progressive wave or mechanical wave. Okay, so it should be a progressive wave, but it's fine. Waves transfer energy without transferring matter, and you will learn something called matter wave in AS also. The angle of incidence of a ray light incident on a plane mirror is gradually increased. To the nearest degree, what is the maximum possible angle between the incident and reflectors? Okay, so this little difficult to understand, but very easy to imagine. Okay, let's say that we have a mirror and this is normal to the mirror. Okay, so we can start from 0 degree. So this is 0 degree incident ray, it will reflect back. Yeah, then let's say that we are increasing angle, then it will reflect like that. So until which angle we can get reflection? So if this is the initial position, we can increase like this, we can increase until like this. So this is 180. Beyond this, it will go back of the mirror, so we cannot have reflection. So 180 is the answer. Next question. Which conditions are necessary for a light to be totally internally reflected? Oh, there are two questions like this. Okay. So two conditions. One, light should travel from dense medium to less dense medium. Two, the angle should be greater than the critical angle, because less than the critical angle, it will just it will just pass to another medium. So option D. Remember, from dense to less dense medium, the angle should be greater than the critical angle. So condition for total internal reflection. Okay. The diagram shows a ray of light passing from air to a transparent substance. What is the refractive index of the transparent substance? So we have to use, we know that refractive index is sine of incident angle divided by sine of refractive angle. So sine I by sine R. So it's sine 40 divided by sine 30. So sine 40 degree is 0.4642, sine 30 is. So whenever we do this calculation, make sure that the calculator is in degree mode, not in radian. So unless otherwise specifically instructed to radian mode. Okay, that can cause some error. Yes. Okay, so rest is baby math. Then we'll have 1.284. We can round it up to 1.29. Now again. The diagram shows a ray of light in an optical fiber. Which statement correctly explains the condition for the maximum transmission of light by the optical fiber? Okay, so there is a relationship between the velocity of the light and the critical angle. Okay, it's a little complicated to explain by animation. I didn't try. So the condition is we should have critical angle as minimum as possible, because only if it is above the critical angle, greater than the critical angle, total internal reflection will occur. If we have very low critical angle, all the rays can pass. Okay, so the glass must slow the light as much as possible to make the critical angle for the fiber as small as possible. Okay, so how does this relation comes is, we know that the refractive index is speed in air divided by speed in that material. Okay, so the refractive index is inversely proportional to speed in that material. So if you slow down, the refractive index increases, and if refractive index increases, we know that refractive index is also 1 by sin c, so the critical angle will decrease. So that's the idea behind this. So option D. Okay, maybe I could have wrote the equation here. Two equations. Mu is speed in air divided by speed in that material, and is equal to 1 by sin c. So the speed should decrease in order for the critical angle to decrease. Yes. Which region of the electromagnetic spectrum is used to detecting fake banknotes? I was trying to find this in the syllabus, but I couldn't But in general, what they do, they'll try to flash the light in UV light in the nodes. If they have fluorescent, then it's a fake node. So UV. Okay. So and there is a YouTube video you can check how banks identify fake nodes using UV light. Maybe I'll post the link below. A sound wave travels at 330 meter per second. The distance between the center of the compression and the center of the nearest rarefaction in the sound wave is 2.5 centimeter. What is the frequency of the sound? It's very easy. Instead of directly giving the lambda, they gave clue about lambda. How does sound wave work? Compression, rarefaction, compression, rarefaction, like that. So distance between two compression is one wavelength. Distance between one compression and one rarefaction is half wavelength. So half wavelength is 2.5 centimeter. Lambda by 2 is 2.5 centimeter. Now what is lambda? 2 into 2.5, which is 5 centimeter. We know that V is f lambda. From that, they are just asking the frequency, right? Frequency is V by lambda. If you do the math, then 330 divided by 5 into 10 power minus 2 meter. So it's just 6600 hertz. Option C. Which waves are used in the medical scanning of soft tissue? Ultrasound. By the way, you have medical physics in A level. Okay, so this ultrasound is a big concept. Which road describes suitable materials for use in a temporary magnet and in a permanent magnet? So I want you to remember like this: soft ion, temporary magnet; hard steel, permanent magnet. Okay, so option B. By the way, what is the difference between soft ion, ion and steel? The composition, presence, amount of carbon, I guess. Yes. A magnetic field is represented in the diagram by magnetic field lines. At which point is the magnetic field strongest? What is magnetic field strength? Number of field lines in the unit area. So in which area its lines are closely stacked together? Obviously A. So this region, magnetic field strongest. Yes. And if they give one point directly A, let's say that some X or something, that has equal strength of magnetic field, because in vertical they have equal distribution of lines. A student determines the resistance of a resistor R. She uses the circuit including a voltmeter and an ammeter. Which circuit does she use? Okay, she want to measure the resistance of resistor. So we can measure from V equal to IR, from that R equal to V by I. Okay. We also know that ammeter must be connected in series and voltmeter must be connected in parallel. Ammeter to measure current, voltmeter to measure voltage. So option D. A diode and a resistor are connected across a variable DC supply. Terminal X is initially positive and a maximum value. Okay. The potential difference across XY is adjusted so that it changes as shown by the graph. So it changes, it's decreasing over time. So you can see the graph. Which graph shows how the current in circuit from XY varies during the same time interval. Okay. So now initially X is high, Y is low. So then this changes over the time. X is it's decreasing, potential decreasing. And if you look at the diode position, it's connected in reverse bias initially. Okay. And if it's reverse bias, then the diode actually allows only the decay current or the negative part of the current. So where is negative part? This region. So only this region will have current. So in 4 options, only D have that region. Okay. Option A have, but it has current in the positive region also. That cannot happen. Only in the negative region, because the diode is connected in reverse bias. When a conductor is in a complete circuit cut across a magnetic field, a current is induced in the conductor. Which statement about the induced current is correct? The direction of the induced current opposes the change causing it. Okay, okay, let's rate other statements, 3 statements, and why they are wrong. The induced current is the same direction, in the same direction as the motion of the conductor. This can be true or cannot be true because this depends on magnetic field direction also. The induced current is in the opposite direction to the, so this is also same. We need the direction of magnetic field. The direction of the induced current is in the same direction of magnetic field. Also this is cannot be said because it depends on the direction of the motion also. So the direction of the induced current opposes the change causing it. This is the right one. The diagram shows a solenoid carrying an electric current. Which row compares the strength of the magnetic field due to the solenoid at point y and z with the strength of the magnetic field line field at point x. Okay, so this is like same question we have seen earlier. X and y inside, they are inside the solenoid, so they will have dense lines passing through, so they will have same magnetic field. Z is outside the coil, so it will go like this magnetic field, they are diversing in Z. So magnetic field at y is equal to x, magnetic field at z is less than x. Sorry, yeah. Conducting wire is placed between the poles of a magnet. When an electric current in the wire is in the direction shown, then the force on the wire acts out of the page. Three statements of different conditions and how the wire is affected are given. Which statements are correct? Okay, we will check the validity of each statement. First, so it's okay. When the current is towards the top, first we are giving current and then we are expecting a force. So it's motor. So we have to use Fleming left hand law. Okay. When the current is towards the top of the page and the direction of magnetic field is unchanged, the force produced acts into the page. Okay, let's consider that this is top of the page and this is into the page. Left hand law. Okay. So field is from north to south. So it's like this, and the current is towards top of the page. Yes, so this is thumb motion, so this goes into the page. So one is indeed right. Okay, and when the current is towards the bottom of the page and the magnetic field is reversed, the force produced acts into the page. So the current is towards bottom of the page and the magnetic field is reversed, so it's like this. So still it goes into the page. So 2 also right. When the current wire in the wire is alternating, the wire vibrates into and out of the page. Yes, so if they change the direction, this is going to change direction, so it will vibrate. So all of them are correct. 1, 2 and 3. Nice. Which type of electric current are in primary coil and secondary coil of a step-up transformer? Okay. So we have to remember clearly that the transformer work based on this mutual induction concept. Okay. So it does not work with DC. Transformer does not work with DC current, or does not operate in DC current. So in both primary coil and secondary coil, it's just AC, alternating current only. Scientist fires alpha particle at a very thin sheet gold and detects the particle that passed through. Which statement about the result of the scattering experiment is correct? D. Okay, let's rate one by one. Alpha particles are attracted to the nucleus of the atoms. No, alpha particles are also positive, nucleus also positive, so they do not attract, they just reflect. Half mass of the atom is concentrated in the nucleus. No, most of the mass is concentrated in the nucleus. Most of the alpha particles are deflected, showing that the nucleus is very dense. No, very few number of alpha particles only are deflected, not most. So only small number of alpha particles are deflected, option D. But some of these deflected through large angles. So this is the right one. The notation represents the nucleus of a gold atom. The relative charge on a proton is +1. What is the relative charge on the gold nucleus? Okay, so we have 79 proton. Each proton have +1 charge. So how many charge we will have? +79. Ta-da! An isotope of hydrogen atom has the nucleide notation 1 2 H. How many neutrons are in the nucleus of the isotope and what is the relative charge on the nucleus? Okay, so we will understand. Down its proton number, top its mass number. Mass number counts number of proton plus number of neutron. So we have one proton. There is 2 in the top. That includes one proton. So how many remaining? One neutron. So it has one proton and one neutron. Neutron doesn't have charge, so the total charge is plus 1. So it will be one neutron and one proton. Number of neutrons 1, relative charge is plus 1. That's all. A radioactive source is placed near a detector. The radiation arriving at the detector from the source is measured from 10 minutes with different materials placed between the source and the detector. Which type of radiation are emitted by the source? Okay, so original count is 5626 when there is nothing between the detector and the source. If you put sheet of paper, again we are having same 5629. So this means that there are no alpha particles, because alpha particles can be stopped by small sheet paper. So no alpha particles. Okay. Then if we introduce aluminum, half of the decrease we are seeing, only 2226 number. So presence of beta particles are there, and if we use thick sheet of lead, then we are again seeing decrease in count. So presence of beta particles and gamma rays are evident from this experiment. Alpha particles are even stopped by few millimeters of air particles. Yes, few centimeters of air particles. Good. The reading on a detector placed near a radioactive material is 536 counts per second. The background count rate is 44 counts per second. The half-life of the radioactive material is 34 hours. So what is the reading on the detector after 68 hours? Okay. So the detector shows the value of 536 counts. What's the background radiation? 44. So what's the actual reading? 536 minus 44, which is 492. Okay. So they are asking what is the reading on the detector after 68 hours. So if 34 is a half-life, 68 is 2 half-life. 68 hours or 2 half-lives. So what will be the reading after 2 half-life? 492 divided by 2 power n. That's the number of half-lives. Okay. So 2 power 2. So if we do the math, 123. So this is the actual calculation. But the detector will detect background radiation also. So we have to add it again, plus 44. So we will have 167 count per second. So option D. A planet in the solar system is at the point in its orbit where it's closest to the sun. Which row is correct? Okay. So let's take this is the sun and this is the orbit. Now we know that planet has moved towards the sun, it goes faster and faster. So it will go like this. At this point we want what's its orbital speed and energy in gravitational potential. So okay, we know that gravitational potential energy is mgh. So this g is not 9.8. This is the gravitational field strength of the sun. Okay, acceleration due to gravity of the sun, that's different. Okay, so the planet will move slow. Yeah, see, when it goes to near that point, it will move faster. We can see one more time, maybe no need. Kinetic energy is half mv square. So kinetic energy will be maximum in that point and potential energy will be minimum, because potential energy measures mg into h, distance from the sun. So that's lowest, so it will be lowest at that point. Okay. What is the main process that powers the sun? Okay, we know that it's nuclear fusion of hydrogen to form helium. So two hydrogen atoms fuse together to form a helium. A galaxy is 3 into 10 power 20 km from the Earth. At which speed is the galaxy moving away from the Earth? So we have to use Hubble law. we know that Hubble h naught is v by d. So we want just the velocity moving away. So v is h naught into d, and h naught value is 2.2 into 10 power minus 18 second. Yeah, I think it's second inverse. Sorry, I made a mistake here. So 3 into 10 power 20 into that kilo, I just add 10 power 3 is 2.2 into 10 power minus 18. So you can actually keep it kilo because answer is in kilometer per second we'll get. So it's 6.6 into 10 power 5 meter per second or 660 kilometer per second. So option A. So we have to be little careful about this point because 6.6 we just directly take 10 power 5 now, then we might arrive little confused whether it's a 6600 or 660 kilometer. So better to count number of digits. An astronomer observes a distant galaxy. The table shows how the distance and the speed of the recession of the galaxy are determined. Which row is correct? Okay. So distance is measured by brightness of a supernova in that galaxy. So there are two distances actually, actual distance and apparent distance. They'll just find this distance gradient, yeah. And the speed of recession, change in wavelength due to Doppler effect, whether it's less wavelength or more wavelength. So blue shift or red shift. So option A. Okay, tada. See you in another video. Bye bye. Yeah, actually, so if you need any particular paper to be solved, or if you need any lecture notes or lecture on some particular topic, please let me know in comment. In future, I will upload. Yes. Bye bye.